Welcome everyone. In this video I'm going to talk about my new project. So I've been working on this thing for several days now, and now it's in a form which can be presented to a certain extent. But I have to tell you right now that this is not the final project. So this is sort of an introductory video for a series of videos where I'm going to present this stuff. And at the end, everything will be published, all the parts, all the electronics, all the wiring, source code, and so on and so on. So at the end, you will be able to duplicate this thing. And I think this will be very interesting because the project itself is a coil winder. And why I built this is because I wanted to wind some coils for myself for some other projects, but it took a lot of time and I could not get the expected quality for the coils, and I thought that this can be automatized to speed up the process, and if it's machine controlled, then it might result in a better final result. So I can wind nicer coils, more tightly packed layers, and so on and so on. So this is basically the first iteration of the machine, or the initial prototype, and at the end there will be like a final piece which works reliably and precisely, and it gives us the result that we expect. So in this video, once again, I will just talk about some introductory stuff. And in the upcoming videos, I will talk more about this circuit, for example, and then I will talk about the improvements. And then in the final video, I don't know when it will come out, but it will come. I will talk about the whole system, and I will show you everything and teach you everything, hopefully. So let's start with the mechanism itself. So if you want to wind a coil, you basically need the combination or superposition of two motions. One is a circular motion, which is just making the turns on the coil. So if we take a coil, then basically this motion. And you can see that this is just a simple copper coil, randomly turned. But yeah, you just feed the wire from one direction and rotate the bobbin or spool or reel or whatever it is called, and then that picks up the wires, and then you start to, let's say, grow this amount of wires on the surface of this spool. But then if you want to turn the coils or wind the coils in a nice way, you need to have a linear motion as well. And that is realized on this part. As you can see, there is a linear rail here, a linear carriage here, and also we have a lead screw here, which transfers or transforms the circular motion into linear motion. So that comes very handy when you want to pack the wires right next to each other, and that's what this part does. So we have two stepper motors for this. One stepper motor will just rotate this based on a recipe, which calculates the amount of steps needed to produce the amount of turns to finish the coil. And then this guy will oscillate back and forth, or left to right, or whatever, again following a recipe, which is basically decided by the width of the coil, the thickness of the wire, and the amount of turns that you want to pack together. So for example, if you have a 1 millimeter thick wire, which is a very thick wire in these environments, let's say, because for example this is just 0.45 millimeters, so roughly half of it. So if we have a 1 millimeter wire and we have a 1 centimeter wide coil, which is a very small coil, then we can pack together 10 turns next to each other, and then we will have a nice arrangement of the wires. So if we want to have 100 turns in a 1 centimeter wide spool, so like half of this, then we need 10 layers. And we want to pack the layer in a fashion that, let's say we start on the left side of the spool, like here, and then this thing has to move towards the right side in order to place the wires next to each other. And after it finished 1 centimeter, so it reached this part, the right side of the coil, it has to start to move backwards in the same way. So we will start the second layer and we will pack the wires next to each other nicely. So this thing is very important in that sense that it has to be precise, so that's why we use the linear carriage, and it has to move nicely. So in fact these two stepper motors have to be coordinated nicely in order to make a nice coil. So that happens here in the mechanism. And yeah, as I said, so this is just a simple linear carriage, 15 centimeters wide. And here is a trick. So this is the end block from a 3D printer, so the hot end. And here we have these, or we can insert these nozzles. And this is a very nice trick, because these nozzles have very nice and small diameter at the end, which is nearly the same as the wire diameter. In fact, you can pick any kind of different nozzles. So for example, this is 0.4, so I cannot fit this wire, but this is 1 millimeter, so I can fit this. So I have like a very nice nozzle which can, let's say, precisely feed the wire to the main shaft here. And then this screw is another cool stuff, because this screw goes inside this block, and on this part we have a Teflon ring inside it. So that helps to, let's say, save the wire, because the wire will not rub against the metal part if it enters, or when it enters the screw, but it will rub against the Teflon ring, and that we know that has a very low coefficient of friction, so it will not kill the wire. It will not rub against something hard, I mean the wire, and it will not remove the layer of insulation from it. It will not damage it mechanically, and so on and so on. So then here, this will be continued, this part, there will be some kind of tensioning mechanism. I'm still waiting for the parts, so I cannot show it right now because I don't have the parts. But there will be a tensioning mechanism here, and then there will be this reel somewhere here. Maybe it's a bit more backwards because I will need more space for the tensioning mechanism. But the way we make the wire tight during the winding is mainly friction based. So we will introduce some sort of friction in this system. So this shaft actually has to not struggle, but do some work in order to pull the wires through this system. So between the reel and the main shaft that we will use to wind the spool. And that will cause or make the wire to straighten up, because you can see that if you start to unwind it, then there are some dents and some deformation in the wire. For example, there you can hopefully see it. So when we apply some mechanical force by pulling it through the system, then that will hopefully straighten it up, and it will lead to a much nicer coil. So, but this part, so everything behind this shaft is still under construction. And then, yeah, this is just the plastic part I printed for the first time. It's a bit messed up, but this is the plastic part which is here. So here goes the nut for the lead screw. And then in between these two pillars, we put this metal block in. and then these holes have the same dimensions as the rail here, or more precisely this car or bearing block here, and then yeah, it keeps everything together. So this is about the mechanism. It's still under construction, and there will be a lot of improvements, but this is just the proof of concept. So coming to the electronics, I will not explain it in very details, because there will be another video where I talk about only the electronics. But what I can tell you is that I'm using these easy driver circuits because I had a lot of these, and it was easy to mount them on some sort of plate because they have holes here and there. And I'm using small motors, so they provide enough current to keep everything in order. So that's very nice. This kind of, I don't know, arrangement can be familiar to you if you check my previous video, because I made a control panel for stepper motors, and this is the same layout. So we have a Nokia 5110 LCD, 2 buttons, and the rotary encoder with a push button. But I have some mechanical problems with the rotary encoder, so it's sometimes difficult to change between the different menus and options, but I will replace it. It doesn't matter right now. So what we have this display and control panel. We have an STM32 or Blue Pill microcontroller. Everything works perfectly on Arduino because the code itself, it's an Arduino, so you can use it on Arduino. But I picked this because it's a better hardware. And then we have the 2 stepper drivers and then the 2 stepper motors. So what we will do is that we have to feed in some physical parameters for the coil that we want to wind, and then we just have to press start. So basically, we have to know what is the diameter of the coil, what is the width of the coil, we have to know what is the pitch, what is the wire diameter. Of course, we can define the speed in turns per second, also the acceleration. That will be important if you want to wind, for example, very thin and delicate wire, because you cannot start very quickly, otherwise you will just break the wire. And there is an option, or there are options where we can just independently move the different shafts. So if we want to start from here or we want to start from here, then we can manually move by using the buttons and the rotary encoder. And basically that's all. So we have to set up the parameters, as I said, width, inner diameter and wire diameter, how many turns we want, and then the speed. And then everything else is a bit hidden, not shown to the user, but it's calculated on the microcontroller. And after everything is done, yeah, we just press start and this will move. And I will try to demonstrate you some stuff just related to the motion. So I will not wind anything. I haven't even tried this to wind any kind of coils yet, but I will do it in the next video where I will have a bit better arrangement, and then we will see what happens. But now I just show you the very basic principles of this, and we will see what happens. So we will need to power this thing. So I'm just using this adapter. It's 12 volt and 2 amps. It's perfectly fine. And I'm using a USB connection for powering the STM32, but I have to notice that these control panels for the stepper motors, it's upside down. So here they have a 5 volt output, and you can feed the 5 volt to the STM32, and then you don't need the USB connection. But still I need the USB connection because I have to play around with the software and so on. So we have a starting screen. Hopefully you can see it. And then let's start in the beginning. So I have some problems. Yes. So yeah, we can change the speed, the acceleration, the number of turns. Let's change it. So what I did, if we move the rotary encoder, we increase or decrease by 1 steps. And if we keep the buttons pressed, then we change by 10 steps. So if we want a lot of turns, then it's more easy to do like this. So this is done. And then the wire diameter is 0.1. We are okay with that. Maybe we want to increase it so we can have more layers within one width, and that's easier for us. So let's increase it to 1 millimeter, let's say. Pitch. This is actually not implemented yet, but it's in the menu system. And then the width of the coil or the bobbin, so the width of this thing. And since the wire width is 1 millimeter, let's make this 5 millimeters. And then the diameter is not important now. It will be important when we want to calculate the consumption of the wire, but we are not interested in that right now, so we skip that. This is just to move the main shaft manually. I will show it later. This is to move I could not find better name for this shaft, so this is the weaver or weaving shaft. And then this is the winding. So we enter this menu and I will press start and hopefully nothing will crash. Let's see what happens. So as you can see, at every 10 turns, right now this is the triggering number, we update the number of turns done, but the last turn is not updated, the last 10 turn. That's just some software thing, I will solve it. But as you can see, the main shaft goes with a certain speed that we defined, and then this goes back and forth. Basically, whenever the main shaft completes 1 turn, that means that the width of the coil increases by 1 wire diameter, then this also moves by 1 wire diameter to a certain direction, depending on where we are on the coil. So let's say we start from the left side, so here, and then this moves 1 turn, then this thing will move to the right by 1 wire diameter distance. And then this does another turn, so there are 2 turns now, and this moves again 1 wire diameter to the right side. So then this will be continued until we cover the distance with this thing, which is the width of the reel, so this width, and then this starts to go in the other direction with the same strategy. So this does 1 turn, and this does 1 wire diameter displacement. So that will be hopefully a good strategy to have a very nice layout, not like this, but like a very tightly packed coil. So as you can see, there are still things to improve, but this is again just a proof of concept and an introductory to my sort of larger project. So that will be it. And then now we can see where is the weaver shaft and also some other positions. And yeah, so every numbers and every details are updated, and that will be very good for the user, so we can get very good feedback on the current position of the stepper motor and everything. So most of the things work now. I just haven't tried it with a coil, but that will be in the next video. So I already started to think about some improvements. And for example, if we want to get better speed and still keep high torque, for example, then this motor has to be replaced. I have a larger NEMA 23 stepper motor, that might be something that I will implement as an improvement, but then I will have to replace the stepper motor driver. But if you check my video in the corner, you can see that that is not a problem, because this code will work with basically any kind of stepper motor driver which has the step and the direction input, because they work with the same principle. The difference between these drivers is just in the circuit, but not in the way that they handle the signals coming from the microcontroller. So that's one improvement. Another improvement is that I will replace this main shaft, so we can put any kind of reel, so it doesn't matter what is the diameter, any kind of reel here. And I saw some solutions where they used some drill chucks, so I will go with that kind of solution probably, and I will see how it works. I think this part will be fine, because yeah, this sideway motion is not really limited in anything. If you want to go for a really precise solution, you can use ball screws here, but for this project it's a bit overkill. And then I will also set up the wire tensioner and see if it helps. So in the next video I will already have a better system here, and also this mess will be inside the box, because now I can see that these things work. So at least the electronics can be put in a box. So this was the introduction basically about this project. Maybe I can show you how to move these things, or I mean, I can show you that I can move these things independently. So I just restarted the microcontroller to avoid any kind of mess, because I haven't perfected the software yet. So I entered this main shaft part, and now if I move the rotary encoder, you can see that the main shaft moves. So this is useful when you want to, for example, manually make the first few turns, because then you can do some tiny adjustments by hand. And there are two options. This is the rotary encoder, or you can keep the buttons pressed and then it moves. This is supposed to move in the other direction, but for some strange reason it doesn't do that. But again, the software is still under development. And then we can move to this motor. And do the same. And let's move from side to side, so you can see that yeah, it moves perfectly as we want. Also, another thing can be that add the end stops or limit switches, but it's not really necessary for me, because I know where it should stop and start. So as you can see, this works as well. Then just run this randomly. So you see it oscillates back and forth while this moves. But this was just some random stuff. So you can see that this started to have some kind of look to it. So the mechanism is almost done, electronics is almost done. Now I have to remove all the bugs, polish the software, do some small adjustments here and there, and it will be done. So I hope you like this project, and if you are interested, please subscribe to my channel and check the notifications, because I will upload a lot of videos regarding this project. There will be a playlist dedicated to this project, so I will collect all the videos related to this coil winding into a playlist, so it will be easier to go through all the steps and find everything. And then if you have any kind of questions or suggestions or something, then please leave a comment, because I'm really curious about this topic. So if you have something in your head, or you want to share some ideas or something, then please let me know, because then I can improve this thing and implement, for example, your ideas and so on. Yeah, so this will be the system, and this will be implemented as a coil binder. So hopefully it will work as I want it, and it will produce nice coils. So I hope you liked this video, and I hope you learned something from this video. Once again, please don't forget to subscribe, leave some comments if you have some questions or suggestions. You can also support me so I can have this project done quicker, or I can buy better parts and so on and so on. And yeah, so basically this is all. So once again, I hope you learned something, and see you in the next video.